Alright guys, so in this video what we're going to go through is the basic process behind how to write a chemical equation. Okay, so as I've written here, there are three parts to writing a chemical equation. Okay, the first part is the ability to write an ionic formula. So an ionic formula is what's called an empirical formula. Okay, and it basically all it does is it expresses an ionic compound as a ratio between two different ions. Okay, so we know that an ionic compound, so an empirical formula, so we know that an ionic compound is basically a compound that's formed between the bonds of lots and lots and lots of different ions. So say we have two different ions, so we're looking at sodium chloride, NaCl. So we have lots and lots of sodium ions and chloride ions. Okay, so we'll call these the blue ions sodium and the yellow ions chloride. Okay, so basically an ionic formula is just lots and lots of sodium ions and chloride ions bonded together. So we can't express an ionic compound as, you know, a certain number of sodium atoms, say, you know, 1,000 sodium atoms and 1,000 chloride atoms. Okay, sodium chloride is defined by the fact that for every sodium chloride, every blue dot in this area, there is one chloride ion, one yellow dot. Okay, so what we do, instead of writing down, you know, a certain number of sodium atoms in an example, we just write down the ratio between the two, which in this case is a 1-to-1 ratio. Okay, now you might be wondering, how do we work out that ratio? Well, whenever we look at ions, when we look at different ionic compounds, we look at ions. Okay, and we look at their charges. So charges can have anything from, you know, charges can be 1 plus, 2 plus, 3 plus, and so on. Okay, they can also be 1 minus, 2 minus, 3 minus, and so on. Okay, and so these charges tell us, describe quite clearly the charge on an ion. Okay, and so what we need to do when we need to figure out the ratio, this ratio between two ions in an ionic compound, we basically need to find out the ratio that will allow the charges to cancel out. So if we have two compounds, compound A and compound B, then we need to put them in such a ratio such that their total charge will be neutral. So if we have, if ion A has a charge of 1 positive, charge B has a charge, ion B has a charge of 2 minus. Okay, then we're going to need, for every one B ion, we're going to need 2 A ions to make the charge neutral. Okay, because one minus ion and 2 1 plus ions will have a net charge of 0. Okay, so we know that the ratio here is going to be 2-to-1. Okay, so we can apply this to any. So in a more complex example, A might be 3 plus and B might be 2 minus again. Okay, so here we need to have, again, a net charge of 0. Okay, so if we have 2 A charges, ions, and 3 B ions, then the total charge will be 0. So there'll be 2 A3 pluses. Okay, so for a total charge of +6. Okay, and then 3 B2 minus charges for a total charge of -6. Okay, giving a net charge of 2 minus. Okay, for a net charge of 0. So we got -6 here, +6 here. So total charge is 0. Okay, and the same goes here. We have 2 A 1 plus for every 1 B 2 minus. Okay, and so that's how we work out an ionic formula. That's how we combine the ions in an ionic compound into an empirical formula, which is just the ratio between the two ions, which is required to make the total charge neutral. Okay, so if we have 2 A ions and 1 B ion, then we write this as A subscript B, subscript 2, sorry, A subscript 2 B. Okay, so that's how we write an ionic formula. Okay, the next part of writing a chemical equation is to balance all the reactants and products. So basically, for every atom of reactant, there must be one atom of product. Okay, so for example, if we have an equation where we have A 2B, like we've written just above, plus CD, C 2D becomes A, C. So keep in mind that A, B, C, and D are all ions here. Okay, so now this looks like we may have worked out from the information we've been provided that this is a chemical reaction that's occurring. Okay, this compound A2B is combined with this compound C2D to produce AC and BD. However, if we look a little bit closer, on the left hand side here we have 2 A ions and we have 2 C ions. And at the moment we only have 1 A ion and 1 C ion on the right hand side. And see that now this doesn't make sense. If we want to conserve mass, we want to conserve the number of atoms or ions, then we need to put a number in here, a number 2 in there, so that now we have 2 A ions and 2 C ions on either side. Okay, so this is called balancing. What we're basically doing is adding a coefficient or coefficients as required throughout the equation to ensure that the number of atoms or ions of a given element on one side is equal to the number of atoms or ions of that same element on the other side. Okay, and I'll do an example of this, of all 3 of these, in a video after this. Okay, and so the last part of this process is, that should not say solid, is to find the state. Okay, so the state is basically every single equation, every single chemical reactant or product that you write in a chemical equation requires its state to be included. So this is very important. Okay, it's very easy to forget, but you can't forget it. So the 3 possible states are, as I'm sure you know, aqueous, gaseous, liquid, or solid. Okay, and so when we're writing an equation, we need to put in brackets in a subscript below basically whether or not a substance is aqueous, gaseous, liquid, or solid. Okay, so we just put it in brackets in a subscript like this. Okay, but when we write an equation, we need to have a way to figure out what state each substance is in. So basically, we need to look for keywords. Often we might be told quite explicitly that a substance is gaseous, liquid, or in fact a solid. However, sometimes there are some keywords to look out for when it comes to aqueous substances. Basically, the words, if a substance is described in a solution, if it's described as being an acid, or if it's described as being a base, then all 3 of these are indicators that the substance is aqueous. Okay. Now, in other situations, so these 3 cases will tell you that a substance is in aqueous state. However, at other times we might need to work out whether a substance is gaseous, liquid, or solid ourselves. So what we do here is we might need to look up data for it. Okay. So what this means is that, to know if it's gaseous, liquid, or solid, we need to look up data such as boiling point, so the boiling point is the temperature at which if a substance is above this temperature, it will be a gas. Similarly, the melting point, if a substance is above the melting point but below the boiling point, it will be in liquid form. And if a substance is at a temperature below the melting point, it will be in solid form. And you can sort of use your common sense to work that out, really. Knowing that things, they go from solid to liquid to gas to liquid to gas as T increases, as temperature increases. Okay, so you look for data such as this, or maybe another one could be, there might be data somewhere telling you the state of a substance at room temperature. Okay, so that's another point that you might use to work out the state of a substance in a chemical reaction. Okay, so these are all the considerations, some keywords up here that you need to look for. And some data that you might need to look up to determine what state a substance is, okay? And for every reaction that you write, it's very important to include the state, okay? To write the state of every substance in the equation just below the substance, just like we've done here. Okay, it's very important to make sure you do that with everyone. And so in the next video, in another video, we'll have an example going through the 3 stages of this process.